Hello, everyone. My name is Michelle Tanakon, and I'm a part of a team of undergraduate students from Toronto Metropolitan University. Today, I'm happy to present our project evaluating the performance of commercial large multimodal models in interpreting mammographic lesions compared with expert radiologist annotations. I will first begin by providing a brief overview of the research that informed our work before handing it over to my teammate, who will demonstrate the solution we developed. Breast cancer is one of the leading causes of cancer related mortality among women, making early detection critical for improving patient outcomes. Mammography is the standard screening method, but interpreting mammograms can be difficult because lesion characteristics are often subtle and subject to variability between radiologists, even when standardized reporting systems like BI-RADS are used. Large multimodal AI models such as ChatGPT, Gemini, and Claude have demonstrated the potential in medical imaging, but there is limited evidence evaluating how accurately these commercially available models interpret mammographic lesions. And our study aims to address this gap. We evaluated three commercial large multimodal models using the publicly available CBIS DDSM dataset, which contains pathology confirmed mammograms and expert radiologist annotations. Each DICOM image was independently analyzed by ChatGPT, Gemini, and Claude using the same standardized prompt to ensure a fair comparison. Model outputs were then compared with clinician annotations across five clinically relevant diagnostic criteria, including lesion detection, lesion count, lesion shape, lesion margins, and pathology. Overall, Gemini demonstrated the highest diagnostic accuracy across all evaluation criteria, followed by Cloud and ChatGPT. All three models performed well when identifying simpler lesion characteristics such as lesion present and lesion count. However, accuracy declined considerably when interpreting more complex morphological features, including lesion shape, lesion margins, and pathology. These findings suggest that while commercial multimodal AI has strong potential to support radiologists by improving workflow efficiency, current models still require further validation before they can be safely integrated into routine clinical decision making. Building on these insights, I'll now hand it over to my teammate Wasti, who will introduce the next part of our project.
Hello, my name is A.S. Swasti. I'm a graduating undergrad CS student at Toronto Metropolitan University, and this is our creation, Terra Comrade, and I'll be walking you through the entire demo. Throughout our investigation, we noticed that the AI models take various inconsistent pathways and tend to hallucinate. And so we thought, what if we got medical professionals into the workflow and make the entire process a little more deterministic, prune some of the absurdity, and so it's easier for the AI to narrow its search. There are options to upload DICOM images here, but we strongly recommend that you stick within the dataset that we provided here, which is our investigation is based on. But for the sake of demo, I will be using one of the demo images here. This is our custom DICOM viewer that we have created. This has two main layers to call the mask layer and the base layer. Our main work here is to overlay the mask layer on top of the base layer, and so that doctors are able to later on trace around the entire lesion or area of interest and take notes on it. For example, we could say something like area of significant interest. And obviously, doctors would have it much more detailed, but this would be included into the AI pipeline. We would save it, and we would start our analysis. And we are met with our analytics. These are the metrics that we care about and the rationale behind them. And there are toggles on and off for all the images and overlays here. We have also included a very helpful table at the bottom for cross summarization. And later on, we're able to send all the data, including the doctor's input, over to the AI for more insights. These are the detailed insights that the AI outputs based on the doctor's input, the systems pipeline. And since our internal system analysis is based on the input and the border provided by the doctor, it gets offloaded to the AI later on. That's how we're able to prune away some of the absurdity that AI produces. And this is Terra Comrade, a representation of the human in the loop model and how doctors can play as the harness or the middleman between AI and patient health data. Thank you.